Thank you so much, Dr. Osama. I concur with every single thing you said, and as a health system lawyer and regulator, I agree that health systems need to be very tightly regulated. It's a real pleasure to be here today. What I thought I would do is I'm going to drill down a little bit into some of the things Dr. Osama was talking about, because I think that for a lot of people, myself included, the concept of health data can be quite confusing. What are we actually talking about? What is going to be in NABID? What is it? Is it words? Is it codes? Is it both? Who is it for? Can we share it? Can we compare it? Can we analyse it? Who has the skills to collect it? And what can it deliver? The answer is, it's both of those things. And what I'm going to do in the next 15 minutes or so is I'm going to talk a little bit about the data journey and what data is, but then I'm going to show you some applications with some of the work that we're doing. So I hope that will illuminate for you what we mean when we talk about codes and why health data has some very unique challenges when we're talking about using it for things like NABID, for population health, for the Australian My Health Record. What are the unique challenges in health data? You'll see there on that slide an image. That is a replica of the Broad Street pump. So I'm just going to take you back in time to 1854, London. There was a cholera outbreak, and a doctor called Dr. John Snow was convinced that cholera was ingested through the mouth. His colleagues did not believe him, but he decided to go on a data journey to prove his hypothesis. What he did, this is how he collected his data, with paper and pencil, or probably parchment and quill in 1854, he mapped the local community, drew the streets, he plotted on the streets, and you can find this map if you Google it, he plotted on the streets, these were his data points, he plotted where everyone had died from cholera. And what he discovered was that their closest source of water, all of them, was the Broad Street pump. So he convinced the local authorities, despite the objections of his colleagues, to disconnect the tap. You'll see there that replica that exists in Soho in London today doesn't have a tap. So he convinced the authorities to remove the tap so no one can get water from the pump, and he solved the cholera outbreak. So just hold that thought, because what I'm going to do is show you how things might have gone for Dr. John Snow if he was dealing with that same problem today. So again, I think it's helpful sometimes to compare the journey that the health sector's on with the banking sector. I'm looking around the room and a lot of you are quite young, so you may not remember these things, but I remember them very, very well. When we were travelling in the 80s and 90s, we had travellers' cheques. That is the way we accessed our money when we travelled, right? So we couldn't access our money anywhere we went. We didn't have these ubiquitous little plastic cards that we have. That didn't exist. It was a words on paper system. And we had to go and you'd take your traveller's cheques and you'd find an American Express office overseas and you'd exchange your traveller's cheques for local currency. That's how we accessed our own money in another country. At the moment, in my opinion, the health sector's really sort of here. We're at a very early stage of our development. Think about it. You can't access your health records anywhere you go. But initiatives like NABID, like the Australian My Health Record, are pushing us in the right direction. But we are a long way off being actually able to access our health records anywhere, not just in your local country. What if you were overseas? Wouldn't you like to access them there as well? So what happened in the banking sector is little plastic cards came along. And for those of us who are old enough, you might remember that when little plastic cards came along, initially, you could only access your money from certain ATM machines. I know some of you are so young. I think you're thinking, plastic cards, machines? What is this thing? But it was true. In Australia, I remember my bank, I could access money from my bank and one other bank in Australia. There were like 5 other banks, but I couldn't go to them because my card didn't work in that machine. So eventually, yes, I know, it's mind-blowing, crazy stuff. Eventually, you could access your money from any machine. And now I do a lot of travelling, well, pre-COVID I did, and I'd go into an ATM machine in some corner of India in a tiny little petrol station somewhere and, stick your card in. You think, can I really get money out of here? And out it pops. And now, even these little plastic cards are disappearing. So I've got a card here with me this week, but I'm really not using it very much. Mostly I'm just tapping my phone everywhere I go. So even the card is disappearing. So for health, I think we're still at the stage where it's like, wouldn't it be great to have a little plastic card where you could access your health? We're so far off. But the bottom bullet point is the one I want to really stress. The way that was achieved in the banking sector over all of those years was internationally standardised information models, messaging systems designed around atoms of data. So let me just hold that thought and I'll just keep moving along. We have international standards in health, we're just not very great at adopting them. So the international standards that we have for health messaging, so it's just a messaging system, is HL7 FHIR. I'm not going to go into a lot of detail about what that is because we don't have time. But it's just a messaging system, a bit like the way the ATM machines used to pass information. But even more important than HL7 FHIR is OpenAIR, which is the international standard health information model. If you imagine the ATM example again, you can't say, I'm going to have this data element up here and this one down here, because we don't like to do it the same way as you. That's why I could only get my money out at certain ATM machines. Everyone has to harmonise and say, no, we're having a standardised information model. You put this here, this here, this here, this here, and then you exchange it. So when we have HL FHIR and OpenAIR, you have what's called interoperability. But that's only part of the story. As Dr Osama pointed out, that's great for clinicians. That's words. We're exchanging words. So what will happen is, someone will pull up your record and the doctor will be able to see the words that have flowed through the system. And they've got context, they can read it, they know what's happening to you. But words are of no use to anyone other than clinicians. Again, as Dr Osama said, you would have seen that slide he had with interoperability with all those codes listed on it. So these are the codes we use in health systems around the world. And as you saw on Dr Osama's slide, it's not one set of codes per country. Every country uses multiple sets of international codes and classifications because they serve different purposes. So we don't have time to go into too much detail on all the different code sets today, but I'm going to focus on one that you saw on Dr Osama's slides. You might have seen it, and it was ubiquitous on his slides. It was everywhere. In every one of those sections was SNOMED CT. There's a very, very good reason for that, because we're going to talk about detail. We're going to talk about meaning. Now, for those of you who have... Anyone watched The Hobbit? Has anyone watched The Hobbit series? Yeah. Great trilogy of movies in about 2014 that preceded Lord of the Rings. This is a scene from The Hobbit, and in this scene, Bilbo Baggins, who's the little fellow sitting there, the little hobbit, he says to Gandalf, the wizard, obviously wizard-looking there, he says, "Good morning." And Gandalf says, "What do you mean? Do you wish me a good morning, or mean that it is a good morning whether I want it or not? Or that you feel good this morning or that it is a morning to be good on. It's a beautiful illustration of health data and the unique challenges in health data. In health data, the same meaning is often expressed with different words. In fact, constantly. There's an example there, and that's from the Australian Digital Health Agency. There's a reference there. When they were doing education on SNOMED CT. So they were explaining there, you can see 4 different clinicians have said the same thing 4 different ways. But it means they all meant malignant tumour of kidney disorder. And that is a SNOMED code in the middle. One of my colleagues who's here today, Cam, I'm going to talk about in a minute from EBM Analytics, he can share with you his frustrations, chat to him later, because he's got one orthopaedic surgeon in his team that he works with who has 2 patients with identical problems, and he describes everything in their medical records differently. And it's very frustrating for Cam, because what do you mean when you use these words? Think about, ladies and gentlemen, the word cold. C-O-L-D, cold. What does it mean? You can feel cold because someone left the window open and it's snowing outside. You can have a cold, you're sick, flu-y. You can have a cold personality. If you are in a respiratory clinic, the person who wrote that in the record might have meant chronic obstructive lung disease. So these are the unique challenges in health, and that's why SNOMED CT has become the world's standard health terminology, because there's a different SNOMED code for all of those things. It's not one code for cold. There's like 30 codes for one word, cold. What does it mean? Because we need to know what it means, otherwise the data's useless. So let me just give you a couple of examples now. First one is with Cam, EBM Analytics. The problem for Cam was that he's a data scientist. His organisation's a data scientist. They want to analyse the data. You can't use words. We don't want words. We want codes. But once you've got the codes, what are you going to do with it then? So you would have seen Dr Osama talk about value-based healthcare, which is becoming sort of there's this global push towards value-based care. What does that mean? So what that means is outcomes. How do we measure outcomes? And one of the key metrics is PROMs. We call them PROMs, patient-reported outcome measures. So how are you going to know what to ask your patients if you haven't got coded data? What are you going to ask them? Say, you've had a knee reconstruction. Was the hospital nice? Did you like your doctor? Was the food good? What are you going to ask them? You don't know what questions to ask your patients if you are not coding the data at a very granular level, right? So you might be, every time that patient's going back for a review to the doctor, maybe the doctor's writing in the record, restricted range of movement, still only 30 degrees, 6 weeks post-op. You miss all that if you haven't got coded data. And once you start to collect that data, you can say, right, we need to be asking patients about range of movement because that matters to them. The next thing I want to tell you about before I finish is COVID. What can we learn from COVID? So the mass spread of pathogens are often not detected fast enough, and I think we all understand that. If you look at the way this works now I'm introducing another partner company, Michelle over here from Allianz Care Technologies. So it's another organisation we've partnered with. We've plugged our products into each other so that we can deliver the codes back to these wonderful companies and they do magical things with them. So this is what happens now with syndromic surveillance. And there's a lot of information on that slide, so I won't read it to you, but just have a look at the slide. Basically, hospital surveillance is locked in silos, there's no real-time community information sharing, and pathogens are widely spread by the time of the diagnosis. You can see down there, by the time you've got a diagnosis, it's day 10. It's too late. It's too late. It's all over the world by day 10. The other thing is you can't use human coders for this. You can understand that, right? Human coders can only code so many records per day, and SNOMED's not designed to have humans coding it anyway. It's a digital product. So you can't have coders saying, oh, I'll get to that next week. I'm a couple of hundred records behind. I'll get to it next week. It's too late. It has to be real-time coding. So you can see there that what we need to do is do syndromic surveillance and capture things instantly. So ACT has developed algorithms where groups of SNOMED codes equal a fire alarm, if you like, a smoke alarm. It can't say you have COVID, obviously, it cannot diagnose. But with some very clever clinicians over many, many years, they've worked out algorithms that say, well, look, this group of SNOMED codes might be a cholera outbreak. Wouldn't that have been great for Jon Snow? This group of SNOMED codes looks like it's COVID. This group of SNOMED codes might be Ebola. So you start to get codes, and then they send alarms. And what we do is we do the coding. And so let me just show you my last slide, and I'm going to stay on this one for a minute. So this is a slide where this is real data. So this is not, I didn't just pull those words out of a hat. This is a real data dump, because I think to contextualise all the things I've said, it's really helpful to see something real. So see these 3 different data dumps. They came into AirCoder. AirCoder spits out those codes. We give those codes to ACT, to their S4 engine. They put them through their algorithm and they alert or not. Now, a couple of things to look at on this slide. Firstly, it is not a word for code match. That's not what this does. So it's looking at concepts. You can see there's not the same amount of words as codes. It is not like the word cough equals that code. It's much more sophisticated than that. Look at the first data dump, 3rd line down. You'll see the doctor wrote dyspnea, then in brackets, difficulty breathing. Then the next thing he wrote is sob. And someone said to me yesterday, oh, the patient must have been sad. And I said, there's another example of meaning. What does sob mean? Now, if you're not a medical person, and this person wasn't, they thought the patient was crying and was really sad. But if you're a medical person, you know it's shortness of breath. So the doctor wrote the same thing 3 times. Dyspnea, difficulty breathing, sob. We don't want the code 3 times. We don't want it, we don't need it. So you need a very clever machine to work out what was meant by that. Was the patient sad? Was it? So that's an example of the sophistication of this system. In the next data dump, you'll see a W, just a W on its own. This is one of the reasons why natural language processing, which is we use principles of natural language processing in AirCoder, but on its own it's not going to be sufficient in the health sector because W is not a word. So natural language processing will ignore it. So that's not a word. I'm not looking at W. But W is critical. W is critical in that context because it's a concept. It's fever with chills is what the doctor meant. And I've often used the example, NLP, I've seen this happen, ignored DD in a medical record. Just 2 letters, DD, ignored it. It's critical because DD can mean diverticular disease, developmental delay, developmental disability. It's got like 10 different meanings, so you can't ignore it. It's important. And the last one I want to show you you'll see the word diarrhoea is misspelt. And I think it's misspelt. I actually cannot spell the word diarrhoea, to be perfectly honest. I don't think anybody can. So you have to be able to handle misspellings, because doctors will write what they want to write. And the other thing that sort of underpins digital health is that you have to get out of the way of doctors. What we don't want to do is say to doctors, listen, you've got to change all the words you use. Learn how to spell diarrhoea, right? It's over for you. I want you to do... no. We want doctors to do doctoring. That's what we want them to do. You write what you write, the way you write it, spelling errors, symbols, do what you do. We need to use smart technology to get out of their way and support them. So essentially, I think that is the end of my presentation. Just to say that we've come a very, very long way since Dr. John Snow and the Broad Street Pump. Thank you very much.